Hello everyone and welcome back to the Kohi Game Engine series. Today we are going to render some geometry on our new UI layer. I would like to take a quick second and thank the supporters of the channel, Eearslya, Wensheng, Caden, and Joel. They are the partners of the channel, which is the highest tier of support for the channel, so thank you very much for that. And I would also like to thank all the other supporters listed here on the screen. Your support is very much appreciated, so thank you for that. So last time we went through the steps of setting up our engine to be able to do more than one render pass, with the intent of having a sort of separate UI layer, if you will. And so what we're going to do today is we are going to go ahead and render two-dimensional geometry onto that new render pass, okay? In order to do that, we are going to have to make some additional changes to the engine, but this should be relatively quick by comparison, okay? So the first thing that I want to talk about is materials, right? Because we have a concept of materials right now that apply to any geometry that we render within the world. And it turns out that our UI geometry is going to require much the same thing out of materials, but only much the same thing at this point, meaning the material system is eventually going to have much more capability and many more features added to it for the world version of it, but the UI really isn't going to need that. And so what we're going to do is create a concept of material type, where we're going to have one type of material for the world and one type of material for the UI. So we need to distinguish that type, and then we also need to modify our geometry system to handle both two-dimensional and three-dimensional geometry. So those are the primary things that we're going to do, and then I also want to get a couple of quick things, quick adjustments made to our loaders. So without further ado, let's go ahead and jump into it. So the first thing that we're going to want to do is go to our resource types.h, and we are going to make a small modification to our material. So if we go down here, we have our material and material config, okay? And right above that, I'm going to go ahead and define our material type, right? So right now we have one for the world and one for the UI. Eventually, we probably will have other material types as well, but for right now, these are how we're going to split it up. The next thing that we're going to need to do is we are going to need to have a concept of that material type within the material itself. So right after ID, internal ID rather, I'm going to put material type. Since we have it here, we also need to be able to load that in or configure it. So right below name, I'm going to put type into our material config. Okay, so the next thing that we need to change is in our material system C file, we need to make a small change to go ahead and read this in, right? So down here, let's get rid of this. So down here, where we are reading in the other properties of the material, right, in our load method, right after, actually right before we load in our diffuse color, we're going to go ahead and set the type, okay? And then a little bit further down, I noticed also that I have a little copy pasta issue here. So this says unable to acquire render resources for default texture. That should say material, okay? So I'm just going to go ahead and fix that as well. And that is all we need to do for that loader, okay? So since we are in loaders, I want to go ahead and just kind of knock out a quick change. So if we actually examine our loader code, specifically the unload, this logic is almost identical between several of these loaders, right? And so I actually want to split this out into a separate files so that we can just reuse that code and not have to sort of do this every single time, okay? So what I'm going to do is under loaders, I'm going to create a new file called loaderutils.h. And in that, we are going to add our defines, our k-memory, and our resource types. We need k-memory because we are going to be passing the memory tag. So we need that because if we actually look at our loader, when we go ahead to perform a free, we actually need the memory tag here and here. Okay, so that's our loader utils.h. All it is going to have for right now is a resource unload. Okay, and this is just a sort of generic method that we can pass information to. Next, we need another new file, call it loaderutils.c, and we will paste in the definition for resource unload, right? So here we just check to make sure that we have the loader itself and the resource pointers, and then we go ahead and we obtain the length of the path, call free on this string as we do in the other places, and then call free here using the resource data size as well as the passed in tag itself, right? And then we go ahead and set the data size to 0 and the loader ID to invalid ID. So this is just a little bit more reusable, okay? So that means that we can then go into our binary loader, for example, and we can go to the top here, include our loader utils. And one other small change that I want to make here as well is right now we are actually duplicating this string before we even confirm that we were opening the file. We probably shouldn't be doing that until we are sure that the file actually exists. So what I'm going to do is I'm going to remove this from here and put it below the file system open call, okay? And then I'll come down here to unload, and I'm basically going to replace all of this logic with a single call to our resource unload, checking of course to make sure that it's successful and warning if it is not, okay? And that just kind of cleans this up a little bit. All right, so we have that for the binary loader. We can actually do something very similar in the image loader. So we can go here to our image loader, go to the top here, we can go ahead and we can include loaderutils.h, okay? And the string positioning here is fine. And once again, we can come down here to unload and just replace this whole thing with a call to resource unload, this time passing memory tag texture. Okay. And next we can go to our material loader, and we can do pretty much the same thing. So we'll come up here, do that. We need to move our string again. So we will move our full path until after the file handle has been acquired. Okay. One more change here is when we set our defaults, we need to go ahead and use our new type default. So we're going to default to a world material, right? And a little bit further down, we are going to add something else to our cases here. So right after the last else if, we are going to check for a new variable called type, and if it's equal to UI, we are going to set the material type to UI, otherwise we'll just leave it at world. And so we'll come back to that in a minute, because we'll need to adjust our material file to accept that change, or to include that change rather. Okay, and last but not least, we're going to go ahead and update our unload function as well. So again, just calling that same resource unload, this time using material instance. Okay, so that's that one. And finally, our text loader is also going to receive this update. So we'll go to the top here, add our include, move our full path down below the file system open, and come down here and update our unload. Okay, so that just kind of cleans up these loaders while we're in here messing with them, right? Okay, that is pretty much all we need to do for our resource types and our loaders. So while we have it fresh on our mind as to what the material file changes are, I'm going to go here to Assets Materials and open up our KMT file for a test material. And all we're going to do is add a new line here that just says type equals world. Okay. And you'll also recall that last time we added this orange lines 512 PNG texture for our new material. So while we're in here with dealing with materials, I'm going to go ahead and create a new one. Okay, and this will be our material that we'll go ahead and load in for our UI to test that. And this is what that file looks like, right? So we have our UI material file, version 0.1. Our name is test UI material. Our default color is white. Our diffuse map is orange lines 512. And most importantly, our type is UI. Okay, so that is going to be necessary for us to be able to reference and use the material correctly. And you'll see why that's important here in a bit. So the next change that I want to make is to our renderer types, because right now, if we take a look at our create geometry call, this assumes 3D vertices, right? Or 3D geometry. And we don't always want to make that assumption, right? Because we might not always be working in 3D, we might be working in 2D. And we don't want to have to create a different call between creating geometry for 2D and creating geometry for 3D, and then also having to have different types for that. Like, we don't want to do all that. So what we're going to do is we're going to use void pointers instead. And we're going to pass in the vertex count, the size of the vertex, and then a void pointer of vertices. And we're going to do the same thing for the indices, just in case we ever have a case where we want to use a smaller type for indices, which we might wind up doing for UI later on. But for right now, we're just going to leave it as the same type. So we want to go ahead and, ahead of the vertex count, we want to add vertex size. Okay, and then we want to change this type here for vertices to just a void pointer. Okay, and then ahead of the index count, we're going to add index size, right? So we pass a pointer to geometry, the vertex size, count, and array, index size, count, and array. This is also assuming a U32, so we need to change that to void as well. So that can be any type. And this interface change is also going to carry over to our front end and our back end, right? So we're actually just going to take this signature here and go ahead and make that update in the front end. So that's the change for the H file. The C file will obviously need the same change. And then obviously in here we'll have to add the vertex size first, then the vertex count vertices, and then the index size, and the index count, and the indices. Okay? And so that is at least all that needs to be done on the front end for that. So next we can come to the Vulkan backend, and where we create our geometry here, we're going to again paste that same signature. Okay, and that also means that we'll need to go to the backend C file and make the change here as well. And before we can actually utilize these changes on the backend, there is a small change that we're going to have to make to our Vulkan types in order to support this. So what we're going to do is come to Vulkan types INL, and we're going to change up the way that geometry data, or the Vulkan internal geometry data, is represented. Okay, so right now we have the vertex count, the vertex size, and the buffer offset, and this vertex size is the total vertex size, which would be the size of each vertex multiplied by this count. And this is really not something we need to store. What we really should care about here is the element size. So we're actually going to rename this to vertex element size, and that's how we're going to use that going forward. So we'll have to adjust the usage of that in a few places. The same is going to be true for the index size. Okay, so we'll go ahead and just rename that, and we'll have a few places that we need to go ahead and utilize that in as well. Okay, so next, if we go back to the C file, there are a couple changes that we'll need to make. First off, there are a couple comments in here that I want to update, and this is just to make things absolutely clear as to what's going on. So I'm just going to be specific about this, that it regenerates the swap chain and world frame buffers, right? Because we're technically doing both. And then down here, we're just destroying the render passes, okay? So in our call to Vulkan renderer create material, we now need to handle this a little bit differently because we have our two different material types and their resources are going to be acquired from two different shaders. And that is where the material type comes into play. And there's a few places we need to adjust this, okay? So what we're going to do, we're going to take this section of code here that is acquiring the shader resources, and we're going to do a switch based on the material type so that we pull resources from the correct shader and get the proper descriptors from that are associated with the correct shader, right? In the case of the world material type, we are going to call Vulkan material shader acquire resources. And for the UI type, we are going to call Vulkan UI shader acquire resources, okay? And if we pass through anything else in terms of material type here that is not valid, we are going to go ahead and throw an error about it and return false, okay? So that's one of those places that we have to actually switch on. The next one is actually right below it. So you'll notice that the destroy material purely is just calling the material shader to destroy resources, and that is not necessarily what we want to do. So what we're going to do is, instead of this single call to Vulkan material shader release resources, we are going to go ahead and switch on this once again on material type, right? So for the material type world, we are going to use the material shader. For the UI, we're going to use the UI shader, okay? And eventually we probably are going to want some sort of pointer to each one of these with maybe some sort of interface that we could use to switch between these so that we don't have to switch case all over the place. But for now, until we lock things down a little bit more, this is how I'm going to leave it, okay? All right, and now in our create geometry, you'll recall that we updated the signature, but we actually haven't changed the usage. Our copy here has already been updated because we renamed these two variables, so these should both point to the proper element size for the index and vertex. So that should be good to go. The next change that needs to be made is down here in upload data range. So right now, here you can see that the old usage is still in place for the vertex element size. This should just be size of vertex 3D. It should not be multiplying the count. Same is true for the index size, right? So we should just be including that, okay? And then what we're going to do is, for each one of these, we are going to calculate a total size, right? So for this one, we're going to say U32 total size is our vertex count times our vertex size, because upload data range is still expecting that. And then a little bit further down here, we are going to do the same thing and just reuse that variable, okay? Now, our upload data range, thankfully, already takes a void pointer for the data. So we can actually just use this as is. We don't really have to modify that function directly. Okay, so one thing I am going to do is, since this is starting to get a little bit long, I am actually going to knock this out to multiple lines. Okay, and I'll do the same thing for the index upload. Okay, and for each of these, we basically should be passing the context pool 0 for the fence, the queue that's going to be used, the buffer offset, and then the instead of the vertex element size, we actually need to use this new total size here. Okay, and then down here we're going to make the same change. Instead of using index element size, we're going to use total size again. That's been recalculated right here. Okay. Otherwise, they should be pretty much the same. One other change that we're going to need to make is we are also incrementing the offsets for both of these by the vertex element size, which is now no longer correct. So we need to increment both of those by the total size instead. Okay. And again, this is still a temporary stopgap until we have free lists. That should be coming soon. One other change we need to make is this free data range is expecting a size, right? So the buffer, offset, and size. So this is only actually passing the element size now. So it actually needs to also pass the vertex count for the old range, right? And likewise, for the one down here, we need to pass the index count, okay? So that way we get the total size for each one of these things, okay? All right. We also need to come down here to destroy geometry and make that same set of changes. So we'll add vertex count there and index count, right? So we are passing the proper size to free data range. Again, that's not really doing anything, but we need to be prepared for those changes. So next we have our Vulkan render draw geometry, which requires some other changes as well, okay? So the first thing that we're going to do is we're going to get rid of this material use and set model, and we're actually going to wind up moving them. So I'm just going to kill this for now. And instead what we're going to do is we're going to make sure first that we have a material, right? And then we're also going to get rid of this apply because we're going to be switching. And right here we are going to be switching on the material type. And so for the material type world, we're going to set the model and apply material using the material shader. For UI, we are going to be doing the set model and apply for the UI shader, okay? So we switch on that error if we have an invalid type there, okay? And this is actually all that needs to be done for the backend. Thankfully, there's not a whole lot to it. Okay, so the next thing that we're going to need to do is we need to make a change to our geometry system to support the changes that we have made to our geometry. So the first thing that we're going to do is we're going to start in the H file, and we are going to change up our geometry config a little bit, right? So right now we have the vertex count and vertices. We are going to change this to actually hold all the same properties as our geometry. So we're going to add vertex size, have our vertex count, and then we're going to change vertices to be a void pointer. And this will allow the geometry config to also handle any type of geometry. Then we have the index count next, which means before that we need to add our index size. So we have the index size, the count, and again we're going to change this U32 to a void pointer, right? And with that, we also are going to go ahead and add a new default getter here for two-dimensional geometry, okay? So that way we have a default getter for that. So this will be for 3D, this will be for 2D, okay? So next we need to hop over to our C file, and in the geometry system state we have our default geometry, but now we're also going to add a default 2D geometry, which is what's going to hold that default. Okay, and we're also going to change this create default geometry to create default geometries because it's going to be doing more than one. So we'll change it there, we'll change it here. We'll also come down to the method itself and rename it, okay, because we're going to be creating more than one. And one minor thing that I noticed as well is in the initialize, there's a tiny bug in here. So right now our array requirement is actually saying that we have a size of geometry times the max geometry count. That's not actually true. It should be geometry reference, right? Because that is what the array actually is. It's an array of geometry references, not an array of geometry. So we just need to fix that there. We wouldn't have run into that until that gets to be a little bit bigger with a lot of geometries loaded, but we don't want to run into that because that would be a pretty nasty bug. Okay, so here we call our default create default geometries. We also need to update this to make that plural. And then we can come down to our geometry system release, which is right here. And I noticed a little typo here. This is still referring to acquire by ID. That should be release. Okay. And then we're going to go ahead and scroll down past our get default, and we're going to paste the definition for our get default 2D, which just returns the address of our state pointer default 2D geometry. All right. And in our render or create geometry, we have our new function signature, which this is not calling, so we actually need to go ahead and update this. So before our vertex count, we need to pass config.vertex size, And as you probably have already guessed, before our index count, we need to pass index size. Okay? And so that will fix that one. And now in our create default geometries, we need to make a couple of small tweaks here. So again, we're calling render create geometry and we're missing some things. So what we need to do here is when we're calling render create geometry for this first one, before the 4, which is the number, or the count, we need to pass size of vertex 3D. So that's going to be the size of the vertex, and then the size of the index needs to be passed before the 6, which is the index count. Okay, and so this is kind of how we're going to load our geometry. We just pass the sizes, the known sizes of the geometry, and then that's stored from then on, and we don't have to worry about it. So the next thing that we're going to do is we are going to come into right in here above our return true, and we're going to create our default 2D geometry. Okay, and what we're going to do is create a new array called verts2D, and this is going to be an array of 2D vertices. We'll zero it out just to be safe, and then we're going to go ahead and use pretty much the same coordinates that are used up here. Okay, and then our indices 2D is a little bit different. This is going counterclockwise instead of clockwise. Because of the difference in projection matrices between the UI and the world render pass, we actually need to use counterclockwise for this version of it. Okay, and then we'll go ahead and pretty much repeat the steps that we do up here where we get the geometry created and set the material. We're going to do the same thing where we create the geometry, this time passing a size of vertex 2D in U32. Obviously bleat about it if it returns false, and then we're going to go ahead and get the default material for this. We're also just going to use the default material in the system. This is probably something we're going to actually wind up having to change because that's a world material, but at least for now we're not actually going to wind up needing that. Okay, so down here in our generate plane config, remember this is generating a 3D plane. We need to change this up a bit to include our vertex size and our index size, right? So we just need to add those things here. And then down here a little bit, we are going to go ahead and just to be absolutely explicit about how this should index, we are actually going to go ahead and cast each one of these to the proper type, right? So that it's obvious how many bytes forward we need to move as we're moving through the array, okay? So we have that. And then down here at the bottom, we need to do the same thing, right? Because now we're being told that it's not a modifiable value, so we need to cast appropriately. Right, so we're just casting all of these to U32 pointers, and that allows us to actually set these values accordingly. And that is it for the geometry system, okay? So we have our all of our system updates, our loader updates that we need, and all of our backend changes needed. So all we need to do is make a couple of things, a couple of changes in our application to hook things up, and we should be good to go. So the first thing I'm going to do is in application C, I'm going to go to the top and add something to our application state. So towards the bottom we have our to-do temp sort of test section here, and we have our test geometry. I'm going to add a new one called test UI geometry, and this is what we're going to hold on to our test plane with, okay? And so the next thing that we'll need to do is we'll need to come down here to where we are loading up our test geometry, which is here. Here we're just calling this to generate our world geometry, our test plane there. and then acquiring it from config and then cleaning up after it. We are going to do the same, pretty much the same thing for our UI geometry, except we're just going to do it in line because it's a little bit quicker. So what we have here is we're going to load up our test UI geometry by setting up a config, right? Setting the size, the count of the vertices, and the size and the count of the indices. We're going to go ahead and set the material name to test UI material, which is what we've set up here. So it should automatically trigger the loading of that. And then we're going to set the configuration name itself to test UI geometry. And then we're going to go ahead and set up some vertices for this. This is just a 2D plane, right? This is pretty much a copy pasta of what is actually in our default geometry, our default 2D geometry. We're just kind of doing it in line. Set up our indices. Here is where we're actually acquiring from configuration. So we pass the configuration and we'll auto release that. And there we are. That should be that loaded. So that'll trigger the loading. The only other thing we need to do is hook it up to our render packet so that we actually draw something. So you'll recall before we actually just zeroed this out. Now we're actually going to go ahead and fill out some render data for this to be able to use as well. So I'm just going to go ahead and add this here. So we have our geometry render data for our test UI render. We're going to set the geometry to the app state test UI geometry. We'll just use a translation matrix, so just keep it centered for now. And we have one geometry, and that geometry is the address of UI render to sort of fake that as an array, okay? And then we'll go ahead and pass that through to the renderer to go ahead and draw. So what I'm going to do now is I'm going to go ahead and build this, okay? And just to be sure, I'm going to go ahead and also run my post build, just to be sure my shaders are built. And let's run. And we see that we have geometry rendering, right? And it doesn't look all that different until you actually go to move the camera around, and then you can kind of see how the layers are different, right? So we can see how this just kind of stays still where it is because it's on a separate layer over the world, right? And that's the reason that we have this, right? Because we want to be able to lay out UI elements on this sort of top layer / render pass over the world, right? And we don't want to be affected by anything that is actually going on in the world, right? So we have the basics of what we need to begin work on a UI system. And this will mean that we can eventually start putting together some various UI controls, maybe start displaying some debug information on the screen, and it'll give us a lot of capability in terms of adding tools to actually be able to edit with, right? And obviously this provides us a foundation to eventually build our editor with, since that's going to be a pretty UI intensive thing. So anyway, that is going to do it for this video. Thankfully I was able to keep this one a lot shorter than the last several videos, but that is going to do it for this one. Thank you guys so much for watching. If you liked the video, please toss it a thumbs up. If you haven't already, consider subscribing. Hit the little bell icon there to get notifications as to when the next video in this or other series drops, and I will see you guys next time.